good peeps, I'm Zaira, and today I'm going to show you step by step on how to balance redox equation in acidic solution. So the substances that I choose is actually manganese and bismuthate. So without further ado, let's jump right in. First and foremost, you have to write the unbalanced equation first. So right now we have manganese, we react with bismuthate and produce permanganate and bismuth. Then we have to separate the redox reaction into half reactions. So we have to identify and write all the redox couples in this reaction. So in order to do that, we have to determine the oxidation numbers, because based on the oxidation numbers, we know which elements undergoes oxidation and reduction. So based on the slide, we can see here, manganese have the oxidation numbers of +2 on the left, while on the right, manganese have the oxidation numbers of +7. So we can see the oxidation numbers is actually increases. So when the oxidation numbers increases, it means that elements undergo oxidation. So manganese oxidized become permanganate. So we can see from the bismuthate, we have the oxidation numbers of +5 on the left, while on the right, bismuth ion, we have +3. So we can see that there is the decrease in oxidation numbers. So it means it undergoes reductions process. And now we know which ion undergo oxidation and reduction, so we can do half reaction equation. In order to do half reaction equation, there are several steps that we need to follow, as we need to balance the half reaction equation. The first one is actually balance all other elements except hydrogen and oxygen. And if you see from the slide, at the oxidation process and reduction process, the other element except oxygen and hydrogen has been balanced. So we move to the second step, which is balance oxygen atoms by adding H2O. So if you see at the oxidation process, we do add 4 water molecules at the left side, since there are 4 atoms of oxygen at the right side. While in reduction process, we do add 3 water molecule at the right side, since there are 3 atoms of oxygen at the left side. The third step is to make sure to balance the hydrogen atoms by adding protons. Protons is H+. So as you can see at the oxidation process, we do add 8 protons or 8 H+ at the right side, because at the we do have 8 hydrogen atom at the left side. In reduction process, we do add 6 protons at the left side, since there are 6 hydrogen atoms at the right side. The last but not least is to make sure the balance the charge by adding electron. Electron loss in the oxidation half reaction must be equal to the electron gain in the reduction half reaction. So in order to make these two equal, we need to multiply by an integer. So we're going to multiply all the half reaction equation of oxidation with 2, and we're gonna multiply all the half reaction equation of reduction with 5. After we multiply the half reaction equation with some integer, we can add it together, add the half reaction together. Then we simplify the equation, where the same species on the opposite side can be cancelled. The equation can be written with the smallest coefficient. Then the last but not least, and it is a very important step, is to make sure to check the equation is balanced. The first one, you need to verify that the type and numbers of atom of the both sides is same, and the second one, you need to verify the sum of the charge between the left and right is also the same. For the final result, where 2 moles of manganese will react with 5 moles of bismuthate and 14 protons, will produce 2 moles of permanganate plus 5 moles of bismuth ion and 7 molecules of water. That's all for me. Thank you.